Hi, my name is Stephen Proud. I'm a electrical designer of 25 plus years of experience. The purpose of this video is to provide you a clearer understanding and to possibly accelerate your job that you're working on. Enjoy.
Okay, today we're going to show you how to connect a Festo CECC-D controller, and we're going to talk CANopen to a CMMS-AS drive, Servo Drive from Festo, and we're going to use CoDeSys version 3.5, Service Patch 4, Patch 1. So I'm just going to quickly start up CoDeSys here. Going to resize it so that we can fit it in our capture here. And we're just going to select the CCC. So we've given this a name, we've given it a directory. We're selecting this one here. Now because we're using CANopen, we want to add our CANopen master manager. And we're going to select the latest device. So we've got structured text, CANopen manager. It's going to create the shell. Now, it's important to understand, I don't know if I mentioned this already, that we're using a FHPP library from Festo. It's a version 3.5.4.8. Okay, so I'm going to open up the library here, add the library, the CoDeSys version here. You know, normally you should be able to just type in Festo and it should find everything, but mine's not working for whatever reason. So I'm going to go click on Festo here, make sure I display all the libraries, and we're going to select this one here. So there's the 3.5.4.8 library. So I'm going to say include. So we're including that library into the project because that's what we're using to map our I/O. The next thing to take care of is the CAN bus. We're going to be communicating at the 1 megabaud. This I'm not going to modify or change at all. Take defaults, add a device, go to Festo, because it's the Festo Drive we're looking for, CMMS-AS. And we're not using soft motion, we're using a FHPP. I'll pick the latest version. I could say all versions, but basically I am picking the latest version. Say add device, close it, open up this. I know that I'm going to set my node address for 3. Nothing else I'm going to change, okay? It's important to understand the starting addresses because the starting addresses of inputs and outputs, that's what we'll use later to map. So at this point we have a base value and we can start bringing in the library and start writing some code. If you want to test to make sure that this is working, you would simply come into here, do a scan of the network. There is an option here. I'm using the classic. I like the classic. Otherwise, we go back to this. So I could come over here and scan the network and say that, or go back to the other view. You would say scan network, select it, say active path, save. And with the CECC, it's important to also know that you can get the IP address of the device here and what it's actually configured for at the time being. So right now I'm just going to download and replace the existing project. I'm going to hit F5 to run it, and we're up and running. So we know we have communications working. I'm using some standard CANopen cables between the controller going direct, and I have my end line resistors in there. The dip switches on the face of the CMMS-AS controller, the top two dip switches are both to the right or on. That is representing the node number. And the very bottom four dip switches are to the right or on, and that represents the baud rate and the dips, the end-line resistors and whatnot. That is all confirmed by going online. This is the project I have here for the CMMS-AS controller. I go to the field bus. I know that I have configured the CAN address. This is the representation of what the dip switches are. They're also shown over here on the right. Okay. And we're selecting FHPP. We're not using CIA 402. We're using a factor group. And what else is there to tell you? This is what I'm using for controller and motor. CANopen is the configuration. It's important that that voltage is low enough for your incoming, whether it be 220 or 120. Homing is via limit switch. Okay, so I have no code. Next thing to do is to add code. Okay, so this is me picking up where I left off here. I've added some code, okay? It's a little too time consuming to add it all in front of you, so in a nutshell, what I've done here is I've added some function blocks. Okay, so the function blocks are from the library. Again, the library is right here, the Festo Motion library. We've got a variety of things here. And at a minimum, to control and execute the moves and whatnot, you need the FHPP control, and you need the read and the write function blocks. These ones over here, you'll see that they all have the word FPC in front of them. That's the Festo parameter channel, and those are used for additional goals within the project. So I've added those. I have, along with the blocks, there are also visualizations for each of the this is a visualization here. So anyway, I've added this to here and put some extra text on here. So I have added each one of these and basically link these to the function blocks that are in the code there. You know, like this x-axis control function block. That's the link right there. And there's really not much else to do. In addition to the standard function blocks, which is simply to get you up and running, I've added some code. You know, I've added an auto mode, cycle reset, and control. So I've added some code itself, some structured text here, and basically I initialize the axis and then I run through a series of moves using the normal method to control the axis. So I'm just going to go and I'm going to download this. I think that's all I need to mention. If you're importing something from my project here, you have to keep in mind that there's the image pool library here. You have to point this to the correct items here. I do have some faults on my own inputs and outputs. I don't know what that is. I've always ignored that. And let's download here. Replace the application. Put the application into run mode. It is running. So at this present time, I do in fact have the minimal I/O active, meaning I have the digital input 4 and 5 active property on the X1 connector. The X3 connector at the bottom has a jumper in it, so I don't have to worry about that. That's the other channel to the DIN4 power stage enable. I have 24 volts on the top, as well as 124 volts, 120 volts on the top supply connector. And of course, I've got my motor and encoder hooked up. So, you know, this is the first thing you look for: supply voltage present. I can just come in here and start toggling some bits. I'll get the axis enabled. Homing is not valid, so of course we have to do a homing. So I'll click on that bit. It starts its home routine. I encounter the limit switch. It comes back off. I come off the limit switch, and now I have a homing valid. Turn the bit off. If I want to go into direct mode now, there's no op mode one. Whenever you minimize this, it doesn't necessarily come through properly. See how if I make these really small, the where you enter the text is kind of offset incorrectly. So for the sake of what we're doing right here, I'm going to enter a property. So I'm in direct mode here. For direct mode, I need to set a velocity. I'll set 20%, and I'll set a target. Now that target and whatnot are based on the direct mode. So this base value of velocity here, this 508, when I'm in the controller here, this 20% is 20% of 508 millimeters. That's my velocity target. The moves themselves will all be executed with this accel and deceleration. The position target itself, this value right here, this 10,000, because I have an exponent of -3, I'm actually specifying 10.000. And of course the whole number. So if I was to type in a 1 there, this would be 10.1 is my request. And how do I execute a move? I turn on the start task. It doesn't work because I have a fault. The fault itself is operating mode. Oh, that's because of what I did earlier. So clear the fault. Now I'm back into mode of running, and I'll hit the start task. It's executed and it's moved. And there's my target. There's my actual, which relate to my actual position right here. Do the scaling in the air. That's how you use this right here. It's very simple. If I want to jog positive, I'm going to jog minus. So that's that. So there are a couple more function blocks here. The direct MP. See how this is base value acceleration, deceleration? Well, this is an add-on to the function block capabilities, the FBC, the Festo parameter channel. This right here, these values right here, the velocity, the accel and decel, Festo function blocks allow you to modify those. So if you do a read, you'll see that the 508 and the scaling for that. And if I wanted to change this to, well, let's see what the max is. Doesn't tell me what a max is, so I'm just going to put a bunch of numbers in here. Then you get this. So you can hover over top, get that max. So I know what that is. I'm just going to leave that for a second. And for the sake of changing this, I'm going to put in 400. And this one right here. So that should be 1 meter. So if I turn this off now and execute a write, and then execute this, now I go over to the Festo Configuration Tool, do an upload. And you'll see that we've modified the values here. The scaling is offset slightly due to some scaling in the controller itself. So that's how that particular function block works. The next one here is a PNU. The PNU, let's go find a common PNU. A common PNU would be like a 127. Well, PNU is a parameter number. That's what that stands for, short form. Okay, so I'm going to execute a FPC diagnostics. And what this is going to do is go get the fault number. And that fault number is 25472. The string for that is operating mode error. If I go to the FHPP manual, the 25472 decimal in hex is 6380, and 6380 hex is the operating mode error right there. This is that particular function block. All that's doing is executing 201 subindex 1. So if I go back to the code here, turn this off, I can only execute one FPC at one time, and I do a execute read, I get the mirrored image of what I've sent, PNU 2011, and I get the actual value 25472. So that's the last fault that was actually given on the controller. If I go to the controller, there are no diagnostics on here, so it's good that you have a diagnostics built into the controller there. The multi-array here, that basically writes a array of it writes a multiple array. I don't know how to, based on the array that you've populated, it writes that array. So if I go into here, I have already populated my array with a variety of values, the PNU, the subindex, the value. These all are relevant. These are all in the manual. The manual I refer to is the documentation that comes with the library, as well as the documentation for the controller itself for this FHPP. Going back to here, I can only have one executing at one time. If I try to execute this right now, it should give me an error. FB other function block is active. It's important to understand that as well. To turn that off first, only when that's done. So it has been done. Okay, so if I go to the position set table, this is what was in the controller. If I do an upload now, this is what I basically modified here, some of these position values. So there you go, I modified a couple. And that is pretty much it. I don't know if this works. No. I'll have to figure out why that doesn't work, but everything else does work. This little thing here is from the manual that comes with the library. It's just showing you what function blocks are capable with what controllers in this library. And finally, the last thing I have to do here is I have a auto cycle here, and all I'm doing is setting some values for position, for velocity, whether it's a relative move or not, and then I turn on the start task. I wait for the start acknowledged back. I turn off the start task. I know that the move is executing, and then I wait for the motion complete, and then I move on to the next move. So I'll explain here step by step. So to get this to function properly, if you go to the HMI, turn on auto mode sequence, turn this bit on, and it's now executing the moves. And they're all direct mode moves. So, and all this will pick up all the information that I'm passing to the variables in the code. And that's it.